In this section we will be solving proportions, and this first statement I have up here, 1/3 equals 20 over 60, is a true statement. That is a proportion. A proportion is two fractions being set equal to each other. Now, one property of proportions is that their cross products are equal to each other. On one diagonal here we have 3 times 20, which is 60, and on the other diagonal 1 times 60 is 60. Basically, a proportion is two fractions that are equal being set equal to each other. Now we have a question, is this a proportion? Now, you cannot cancel across an equal sign. You can only have cancellation across a multiplication sign. Quite often you see a question mark over the equal sign when you're determining whether it is a proportion or not. What I like to do to keep the numbers small is I like to reduce any fractions I see here before I try and do any solving. 4 goes into 24 6 times, so I can reduce that to 1/6. And rewriting the upper left corner here as an improper fraction, I would have 3/2 to 4. Is that question mark over my equal sign equal to 1/6? Now what I'm going to do is I'm going to cross multiply and determine whether the cross products are equal. The diagonal 4 times 1 is rather easy to do. We just get a product of 4. On the other diagonal, we're multiplying 3/2 times the whole number 6, which I will write as 6 over 1, and then I can cancel across that multiplication sign. 2 goes into 6 3 times, multiply across and get 9. So the cross products are not equal to each other, and therefore this is not a valid proportion. Sometimes we're being asked to write a proportion from a statement, and in this case 7 is to 21. That can be written as 7 over 21, as turns into our equal sign. 5 is to 15. Notice the order in which these are written down. It just goes 7 over the 21, 5 over the 15, and everything works correctly. Now, both of these fractions can be reduced to 1/3, and therefore we know that these are equivalent to each other. But we can also find the cross products and find out that each of them is 105 and determine that this is a valid proportion that way also. Now let's solve some proportions. Now that basically means find the missing value. These are going to be a true equality between the two, and before I cross multiply and look at each cross product, I like to reduce my fractions. And I cannot cancel on a diagonal. I can only cancel within each fraction. I notice that 20 and 28 are each divisible by 4. So I can divide them and get 5 and 7 that way, and then really there's no work because we can see 5 over 7 equals 5 over something. Well, that x must just equal 7 automatically. So that was a pretty quick and easy one as a first problem. Now let's solve the proportion. 49 over n is equal to 14 over 18. Our goal is to find n, and I'm going to reduce the fraction 14 over 18. They're both even. Dividing each by 2, I get 7 over 9. So I now have 49 over n is equal to 7 over 9. Now I think this one can be done in our heads because we can notice that 49 is equal to 7 times 7. I can either divide by 7 going to the right, or if I'm going from right to left, I'm multiplying by 7. So I could do the same thing down below and multiply by 7 and find out that n is equal to 63. But that does not always work. But what does always work is cross multiplication, because these cross products should be equivalent to each other. One diagonal, I like to do the one with the variable in it first, is n times 7, which gives me 7n. The other diagonal is 49 times 9. I'm going to go off to the side and do some multiplication. 9 times 9 is 81. Carry my 8. 9 times 4 is 36. Plus that 8 is 44. And I get 441. And then I have our first equation of the course. Basically, we're trying to solve this equation, and we're asking 7 times what makes 441. I want to undo this multiplication by 7 by dividing each side by 7. So if I take 441 and divide by 7, that should give me the value of n. 7 goes into 42 6 times, giving us 42. We can subtract and get 2, bring down our 1. 7 goes into 21 3 times. And so there we have n equals 63, which matches what I told you intuitively. This process on the right always works. This process on the left only works when the numbers are nice. Now let's solve the proportion 16 over 12 is equal to 21 over x. And I'd like to reduce this first fraction here. I cannot reduce the 21 and the 12 because that's across an equal sign, and I can only cancel across a multiplication sign. We can cross multiply across an equal sign, but we cannot cancel across an equal sign. So I'm going to look at the 16 and 12. They both can be divided by 4, and that will give me 4/3. So now I have 4 over 3 equals 21 over x. I don't have a nice way to go from 4 to 21, so I have to cross multiply. The diagonal containing the x has a product of 4x, and the diagonal without the x, 3 times 21, is 63. So I can say that the 4x and the 63 must equal each other. And what I'm going to do is I'm going to divide each side of the equation by 4. Now I happen to know, just from my clock math, 60 minutes and an hour, that there are 4 15-minute periods in a 60-minute hour. So I know that that goes in 15 times perfectly with 3 left over. And that would be 15 3/4 as a mixed number. We could also write that as an improper fraction, 63 over 4, and just leave our answer there. Or we have the alternate choice of writing that as a decimal, 15.75. Any of those three are considered correct. Here we have another proportion. 0.5 divided by x is equal to 1.8 divided by 9. Now I look at this here and I go, ooh, 18 and 9, that's kind of nice. What if I write this as 9.0 and I multiply that fraction by 10 over 10? Now what I've got is 0.5 over x is equal to 18 over 90, which is a little bit nicer. And I'm going to actually divide each of these by 9. Maybe I'm making more work for myself than I want to, but I like to first just get rid of the decimals. Now let's simplify this. 0.5 over x is equal to 2 over 10, which reduces to 1/5, but I think I'm going to leave it here and do my cross multiplication, because one diagonal has a product of 2x, the other diagonal, 1/2 times 10, is equal to 5. So I've got the equation 2x is equal to 5, and if I divide each side by 2, I have 5 halves, or 2 and 1/2, or 2.5 if I want to write that as a decimal. Any three of those could be considered correct. Now let's solve the proportion 7 over 1/3 is equal to 1/2 over w. Notice how I've darkened one of those fraction bars so I could really tell which is the main fraction bar. When you have more than one fraction bar in a fraction, it's considered to be a complex fraction. And we've got to be careful with that. I don't want to mess with reducing, I just want to get rid of this format. So we're going to cross multiply right off the bat. The diagonal with the w in it gives us 7w, and the other diagonal is 1/3 times 1/2, which is equal to 1/6. So we have the equation 7w is equal to 1/6 because the cross products should be equal to each other. So I want to divide each side by 7. So I'm going to just write divide by 7 here and divide by 7 on the right. And on the left, I'm just going to have w by itself. On the right, I'm really dividing by 7 over 1, which means I can multiply by the reciprocal 1 over 7 and see that the product will be 1 over 42, which I think I'm going to keep in that form because I do not want to divide and find a decimal equivalent.